Yeah, let's find the quotients here. 480 divided by 3. Let's practice some long division. How many 3's go into 4? 1. 1 times 3 is 3. 4 minus 3 is 1. Bring down our 8. 3 goes into 18 6 times, right? And that'll be the full 18. And then we still have that leftover 0. So we got to bring it up there. So 160. Whew! Good practice. 365 divided by 5. 5 goes into 36 7 times. That'd be 35. Which leaves us 1. Bring down the 5. 5 goes into 15 3 times. So we get 73. All right. 459 divided by 9. 9 goes into 45 5 times. Subtract it, bring down our 9, and 9 goes into 9 1 time. So 51. 288 divided by 6. 6 goes into 28 4 times. 24. I'm going to have to sneeze here in a minute. Bring down the 8. 6 goes into 48 8 times. So 48. And then 354 divided by 2. 2 goes into 3 1 time. 2 goes into 15 7 times. And 2 goes into 14 7 times. So 177. All right, today we're doing some divisibility rules. Eventually you're going to have to find factors of numbers, which are numbers that make up other numbers. So like 12 could be 2 times 6. Those would be factors of 12. It could also be 3 times 4. So we're looking for patterns with some divisibility rules. So first thing you're going to see is divisibility rules for 2, 5, and 10. Now these are things your brain probably already knows. It's divisible by 2 essentially if it's an even number. So if it ends in 0, 2, 4, 6, or 8. As long as it's even, it's divisible by 2. For 5, it has to end in a 5 or a 0. And for it to be divisible by 10, it needs to end up with a 0. Is the first number divisible by the second? Explain. Is 567 divisible by 2? No. Because, whoops, that's BL's. Because it is odd. For it to be divisible by 2, it needs to be even. It needs to end in 0, 2, 4, 6, or 8. Is 1015 divisible by 5? Yes, because it ends in a 5. 111,120 by 10? Yes, it is, because it ends in a 0. Awesome. We're going to try a few more here. You know what? You could try these ones pretty quick. Is the first number divisible by the second? Explain. So pause here, try it. I'll write it out right now. 160 by 5? Yes. Because it ends in a 0. And remember, for 5, it needs to end in a 0 or a 5. 56 by 10? No. Because it does not end in 0. 53 by 2? No. Because it is not even. Or you could have said because it's odd, or because it doesn't end in a 0, 2, 4, 6, or 8. And is 1,118 divisible by 2? Yes, because it is even. Even. Awesome. All right, let's see what else we got. Oh yeah, divisibility rules for 3 and 9. I gotta sneeze. It's coming. It'll show up right when I'm in the middle of talking, and boogers will shoot everywhere. All right, so to figure out if it's divisible by 3, you need to add up the digits and then see if that number is divisible by 3. Same rule for 9. If it's divisible by 9, you add up the digits and see if it is divisible by 9. Now, one good thing is, if it's divisible by 9, you know it's divisible by 3 as well because 3 goes into 9. Okay, alright, so let's try some stuff out. Is the first number divisible by the second? Explain. 567 by 3. Well, let's add the digits up. 5 plus 6 plus 7. 5 plus 6 is 11, plus 7 is 18. And does 3 go into 18? Yes. And even if you didn't know that, you could say, oh, 1 plus 8 is 9, and 3 goes into that, right? So yes, because the digits add up to 18, which is divisible by 3. 1015 by 9. We have to add up the digits. 1 plus 0 plus 1 plus 5. 1 plus 0 is 1, plus 1 is 2, plus 5 is 7. Is 7 divisible by 9? No. No, because the digits add up to 7, which is not divisible by 9. 9 does not go into 7. So I have 4 that I would like you to try. Try them out. I'm going to go over them right now. 64 divisible by 9, well, let's see. 6 plus 4 is 10, and 10 is not divisible by 9. No, because digits add to 10. 472 by 3. 4 plus 7 plus 2. 4 plus 7 is 11, plus 2 is 13. 13 is not divisible by 3. No, because the digits add to 13. 174 by 3. 1 plus 7 is 8, plus 4 is 12. 12 is divisible by 3. Yes, because the digits add to 12. 43, 542 by 9. 4 plus 3 is 7, plus 5 is 12, plus 4 is 16, plus 2 is 18. And 18 is divisible by 9. Yes, because they add to 18, which is divisible by 9. All right, now we're going to talk about factors. And again, factors are numbers that multiply into other numbers. So we're going to be pretty comfortable with listing all factors of a lot of the numbers that we work with. There are 20 students singing at a school concert. Each row of singers must have the same number of students. If there are at least 5 students in each row, what are all the possible arrangements? All right. So let's think about numbers that multiply into 20. The easiest one to do is 1 times that number. So 1 times 20 would be an option. Cool. Does 2 go into 20? Yeah, 2 times 10. Does 3 go into 20? No. Does 4 go into 20? Yes. It's 4 times 5. And this is it. This is all the possible combinations that multiply to 20. And yes, you can flip them, you could throw in negatives, but that's not what we're talking about. We're just talking about numbers that make up other numbers. So each row must have the same number of students, and there has to be at least 5 students in each row. So to have this be at least 5 students, it could be one row of 20. Now that's probably not what they're talking about, but technically that works with what they said. You could have one row of 20 students. Or if you need at least 5 kids in each row, you could have 2 rows of 10. Or you could have 4 rows of 5. These are all the possible chair setups for this school concert. So I got 5 parts to this question here. Let's get a little bit smaller here. List the positive factors of each integer. So those shouldn't be too bad. And then what are all the possible arrangements, for example, 3, the one we just did, but with 36 students singing at the concert. So let's think about the factors of 36. So up here, A through D, you're just listing the factors, which we'll pause and you'll try in a second. Here we have to list the factors of 36, which could be 1 times 36. 2 goes in there because it's even. 2 times 18. 3 times 12 gets you 36. 4 goes in there. 4 goes in 9 times. And 5 does not. 6 times 6. So here are all the factors of 36. If we need at least 5 students in each row, we could have 1 row of 36. We could have 2 rows of 18. We could have 3 rows of 12. 4 rows of 9. Or 6 rows of 6. So on these ones, you're just listing the factors. I'd recommend just start at 1 and build from there. So let's do A together and then try out the other 3. So with 10, start at 1, 1 times 10, great. Then build up. Does 2 go into 10? Yes. It's 2 times 5. Does 3 go into 10? No. Does 4 go into 10? No. Then we're back at 5. So once we hit the factors on this side, we know we have all the factors. So try these out, see if you can list all the factors of each of these numbers. Here, 1 times 21, or 3 times 7. 24, 1 times 24, 2 times 12, 3 times 8, or 4 times 6. 31 is a prime number, which means all we have are 1 and 31. This might be the last example. That's it. That's it for the notes today.